y por la KNU, Korea National University of Education, así como la Legión de Honor, la más alta distinción francesa creada por Napoleón.
Edison, hay que pedirles a las personas colegas que se han ligado a través de Zoom, que por favor eviten enviar mensajes. Por favor.
Ya. Y por favor, los micrófonos los cierren. A las personas que están conectadas por Zoom, por favor, su micrófono lo pueden apagar. Gracias. Bien, doctor Yemari, para nosotros es un honor tenerlo acá en la universidad. Creo que es un preámbulo para que nosotros sigamos haciendo conferencias también con profesores importantes del mundo en matemáticas. Y bueno, muchas gracias, profesor, por su presentación y por su asistencia. Thank you very much, Dr. Yemari. Now you can talk about your conference. Thank you very much. You can start. Okay, thank you.
Muchas gracias.
Okay, gracias.
Muchas gracias por las palabras tan amables. Actualmente es un gran placer para mí de tomar la palabra hoy por invitación del Departamento de Matemáticas y Estadística de la Universidad de Nariño. Esta universidad, con su lema que nos compromete a aprender para saber, pues sin saber no hay posibilidad de acción, tantum possumus quantum scimus. Tiene una larga tradición. Su fundación se remonta al año 1712, es decir, hace 313 años. Ella honra a Antonio Nariño, quien fue un gran combatiente, pero sobre todo un gran luchador por la libertad y por la emancipación a través de la educación, y cuya reforma contribuyó en la Nueva Granada. Quisiera que mi trabajo en este sentido sea un modesto tributo. Y aquí una nota. He notado que este número 313 es un número particularmente colombiano, porque hay eso computación. No sabe si muchos gentes saben. Es computación. Es que lastimo que no puedo continuar mucho en español, porque mi español es desesperadamente mal. Y no es una razón para mí no de hablar. Muchas gracias por la invitación. Gracias especialmente a Fernando Soto y also al profesor Fernández Mosquera y también a todos los amigos de América del Sur que yo conozco. La geometría, the dynamic geometry was born with CABRI GEOMETRE, first presented in the world in 1987 during ICME conference in Budapest. Today, it's a fully established concept. Indeed, there is a wide variety of research and scientific publication from numerous countries across 6 continents, testifying to the indisputable results obtained by students, good results obtained by students in the way they deeply understand mathematics and more generally science. Dynamic mathematics is a more recent concept. To characterize it, I would say that it's a generalization of direct manipulation applied to any type of mathematical object through visual and tangible representation that allow students to experiment and become familiar with the corresponding mathematical facts. I would now like to focus on what is new in CABRI, especially its free version available as web application capable of running on any device, desktop, computer, tablet, or even smartphone. Without going through an exhaustive overview of CABRI Express, I would like to highlight some of its recent developments. CABRI Express continues what made CABRI GeoMet famous, namely a very high ease to use, this ease to use is widely recognized, a great simplicity of handling, all combined with a great robustness from a mathematical point of view. Some examples of the adaptation for young learner, particularly those learners who are dyspraxic, CABRI now offers augmented reality version of the traditional geometry tools, compass, ruler, set square, protractor, and protractor, not to mention the calculator, which replaces today the slide rule. This allows placing a bridge between the two worlds of geometry. On one hand, the world of pure drawing, concreto, on the other hand, the one of theoretical geometrical objects, more abstract. So here I will demonstrate rapidly some of those extended reality, augmented reality tools in CABRI. So I said compass, regular, ruler, square set, and I don't remember the name in English, transportador. For instance, with today, if you want to draw a circle, you can either go to the standard regular circle tool here to create a circle, but this is not very appealing for students because the circle is created at once, and it's a very different feeling of taking the compass here and clicking and drawing like in the reality. You see that the compass is able to follow the movement of the mouse, and finally I will complete the circle. And this way I could also create a line using a regla graduada, and with this ruler I can create, for instance, a line segment of exactly in millimeter 40, I mean 4 centimeter exactly. And this segment of a given line has the property that the two extremities are behaving the same way. You can drag this one or this one. It's not so common to have this possibility that mimics exactly what is happening in the real world. If I would use a esquadra, I would put the esquadra along this side here and say, have the click here. If I want the line on this side, I'll go here. If it's on the other side, my esquadra will rotate automatically. Finally, I can choose, say, this one, this point, and draw a line. And again, with this line, I could put here a length of, you are not surprised that I'm choosing 3, because with the regla graduada, I will now not create a line segment, but I will simply measure the distance from this extremity here, this point, to this point, and it is exactly 5 centimeters, but the line segment is not created because in this case, I wanted simply to measure the distance, not to create a line segment. So this is the 2 facets of this tool, Esquadra. Finally, I would mention that, for instance, we have paid a lot of efforts to give the possibility for students who are dyspraxic, who have difficulties with movement of the mouse, etc., to be able to drive the construction using the keyboard. Here I pressed with the mouse on the icon of the keyboard, but now I can move. You can't see my keyboard right now, but I'm now have a big cursor, and I am now moving the cursor horizontally or vertically and using the so-called flechas on the keyboard, not the mouse. The mouse is not, I'm not touching the mouse. I would like to create another circle. I could go directly to, if I am counting right, the circle tools. The compass tool is in the 1, 2, 3, 4. I press the key, the 4 keys on my keyboard, and it opened rapidly the pile, and here I can move until the compass tool. And if I even still not using the mouse, I will press the space key, and with this to validate my choice, like this. Now I'm back with the compass, and I could continue my construction, and I'm still not using and it's easy for the students who have difficulties in moving the mouse because they cannot really control fine movements. We have been testing that this is working quite a lot, and it makes possible for those students to participate to the classroom exactly in the same condition as the other ones. If not, they would be disadvantaged by the fact that they cannot realize the drawing. Here they can manipulate and make construction exactly as their classmate. I will not spend too much time on this. If I want to, if we would have more time, I could come back on this, because I've not shown you too much of this. Those tools, I think it's very, those evolution of the tools is quite an interesting feature of this version of CABRI Express. Let me nevertheless move forward and come here. And so, as you probably noticed, today everyone talks about AI. Then why not in CABRI try to model the elements underlying machine learning? Let us begin with some elements of the historical context of its development. Its origin, the origin of machine learning, lies in computer vision, or more precisely in pattern recognition. Let us take the example of handwriting recognition, manual handwriting or printed writing, and to recognize such things like numbers, as shown below. For us, there is absolutely no problem reading this number 505, even in Spanish, so 5, 0, 4, 1. And it's instantaneous without even paying attention. However, for babies cannot do that. But from 2 or 3 years old, starting with 2 or 3 years old, some can read already some of the numbers which are recognized by young children. And by 5 or 6 years, in principle, all numbers are recognized by children, even the 0. What happens in the interval? Learning occurs, as we know, learning and vision occurs at the level of nerve cells, which adapts. Recall that, as we know today, human vision occurs mainly in the primary visual cortex. This cortex contains around 140 million nerve cells, neurons, interconnected through about 100 billion connection synapses. Recall that the cortex is 140 million. It's about 1/30 of an iPhone. The cerebro humano in total has 100 milliones. It means it has as many neurons as 20 together, 20 iPhones. And compared to the cerebro of a hormiga with only a quarter of a million. Research and development in this field began a long time ago. For example, in the US Navy, as early in the 42, 43, with the article Logical Calculus of Ideas Immanent in Nervous Activity. The idea was to recognize, the goal was to recognize light signals, such as those from lighthouses. Light, light, dark, light, 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 dark, etc. To recognize them automatically. And this, I will below show one of the first attempts to modelize a system able to do this, what was called a perceptron. Here I have a perceptron with 3 entries, x1, x2, x3, and 1 output, y. Of course, for more complex problem, we could have arrays, more multi-level arrays for more complex tasks. I would like to take the example of a perceptron designed to recognize the Boolean function NOR. I mean, ni, como en no quiero ni café ni té. Here we have a perceptron as designed in the around 57, 58. We have entries here, O or 1, a second entry, O or 1, and we have weight, Y1, YW2, and it produces an output, which is the computation of the value of the entry, x1 times y1, where y1 is a weight, the same for w2, which is another weight. So we compute some kind of convolution of the two quantities, and we add a threshold B. We compute this quantity. If it is bigger, the convolution, than minus B, we said that the output is 1, and if it's not, we say it is 0. Of course, if we put pesos, not the pesos Y1, Y2 a little bit at random, then there is no high probability that the result will be neither A nor neither X1 nor X2. Para todas for all the possible values of the entries X1 and X2. Let me try here to change the entry. You see, if I go here to 1, it used to be verdadero now. As soon this one is 1, the output is false. And here, if I have another entry going to 1, it stays also false. The only possibility for me to show a verdadero output is that both entries are 0. It is exactly what the function Nini, which is very often called NOR, the function, the realization of this function. And actually, I can show you the values that we had chosen for W1. We have here 1. For W, we have 1 also, very simple values. And for B, I choose 0.5. And if I let the computation go, you see that this is the result. And now it's the total result is less or equal to the objective value 0.5. So this is true. And as soon as I'm here minus 0.5, I'm below. Here I'm I am even more below. So the result stays false. Let me go a little bit further. The idea of one of the first researchers in this domain, Rosenblatt, was to use the valores, the exact value that of the function to, of the objective function to modify progressively the weights, to adapt the weights to progressively obtain better results. For this, it was done by a series of iterations correcting the threshold B and the weights W1 and W2 such a way that to take into account the error. We will see how we could train this virgin perceptron, a perceptron with all the weights equal to 0 as well the threshold to recognize the function and the function E. So here I'm starting with still the same model. Here are the entry. Here is the value of the threshold. Here are the value of W1, W2, and I'm starting with 0, 0, 0. And I will test what's happening for 0, 0. I mean exactly what I have here. The result is 0, so I will, excuse me, I was too fast. I don't know if I can go back. No, it won't function as I would like. So here are the successive value for 0, 0. The output is, the wanted output is 0. What I find is verdadero, it means I found 1. So the error is the real value, the wanted value minus what I received, I mean minus 1. So it means that the algorithm is simply to, at each step, when we do another experiment, we change the threshold B by B plus eta, the error, times the error. So the error is the reference value minus what I obtained here, and multiplied by a certain tasa, eta. Here we will take, for simplicity, we will take eta equal 1. And for the weights, we have the same formula here. This is just a very simple algorithm, the very simple idea which is behind this system. Actually, to accelerate the things, in reality, we have method slightly more complex, but essentially, this is the basic idea of the algorithm. And at the end, it converges for the values for the W1, we obtain B equal minus 3, W1 equal 2, and W2 equal 1. Let us try here. As I said, I replace this. I cannot replace, so my mistake here. Is this? I will come back here later, because now for people knowing CABRI, you know that it's possible to block some values, and now I cannot change them. I cannot make the demonstration, but I could show you what are the values for W1, W2, and B that I am obtaining after some iteration. You see that the W1 will converge with a certain value 2, and the W2 will converge where 1, and this one will converge. This is the number of iteration. Here are the values. We obtain on this way a system that has automatically learned from the examples how to recognize the function end. And this is exactly what is happening on systems that are recognizing, for instance, handwriting or letters or digits. It's time now for me to return to more geometry, and more specifically to the concept of macro. I could say that a macro allows applying all the steps of a more or less complex construction at once. Let's just take the example of the centroid, and I will show that even if the macro tool is not available as an entity in the current version of CABRI Express or even CABRI 3D, it's always possible to implement this concept. For this, it is enough that the software, if it's enough modern, that it has functionalities like the functionalities like copy-paste, copiar-pegar, on an intelligent way, and the very important functionality in dynamic geometry, redefinition. Redefinition, which is well known by people using dynamic geometry and especially CABRI. Let me show you an example. So here I have a triangle, and I would like I would like to have a macro, a tool that would help me to repeat the construction of the centroid. If here I have I will consider a triangle somewhere on my sheet of paper, a triangle, a different triangle. It has not to be the same as here, and I'll construct, as everybody knows, I'll construct the centroid using the two medians. I mean, I need the punto medio, say of one side and another side. And I need now, if I double click the tool on the left, it becomes yellow. And when it's yellow, it means that I can continue to use the tool even after having used it once. So I will not have to go again to the pile and to choose again the tool. It will continue to work with the same tool. So I create one line segment, another line segment, and here the point, which is the centroid. And there is no need for me to explain why it is a centroid. And if I would like to apply this construction several times rapidly to other triangle, one way is to use this model and simply to say redefine. So I will hide the construction. Pardon. Hide the construction. Double click to hide several objects, the point and the point. Excuse me. And now I can use the redefine tool to simply say I will redefine this point to this point, this point to this point, and this point to this point. So I have now the centroid on my target triangle. But this was not such a good idea because now I have somehow two triangles here. I would have been clever in saying better that the centroid actually is not too much the centroid of a triangle, but is a centroid of three vertices, like that. Three vertices, and given three vertices, I can create their centroid in choosing midpoint, 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 punto medio, and midpoint on between this, and between this and this, and again take the two line segments like that, and at the intersection, create the centroid. Now I can mask the construction line. I go to here in Occulta Mostra, and I will occult the construction things. It's better to take the double click like this one, and this one, and leave the Mostra Occulta tool. And now I can redefine the initial point, the three initial point of my pseudo macro, and say I will simply redefine this point here, this point, why not here, and this point, and this is a way I could repeat this construction many times at different places if needed. Let us take a more sophisticated example, not so trivial example. I'd like to look at the construction of the tangent to a conic at a point on the conic. Of course, for a circle, everybody knows how to do that. It's not so. It's not such a challenge. For the sake of the presentation, I will show that if you have simply to make clear what is the problem. The problem is I have a point on a circle, and I'd like to have a way to construct the tangent at that point. And everybody knows that an easy way is simply to have a radius line segment and take the perpendicular line, and we are done. It's a perpendicular line like this. So this line is definitely a tangent line. On a conic, how could we do that?
Teacher, excuse me.
Yeah.
We can't see the construction because your head is behind the presentation.
Excuse me?
Ils peuvent pas voir la construction.
For what reason?
Yes.
You don't see my screen?
Is before the construction. Su cabeza impide que veamos la construcción en la pantalla.
Sí.
¿Es posible eso?
¿Qué pasó? Ya no entiendo qué es el problema.
We can't see, it's impossible see the construction because your head is before the screen.
My head?
Yeah, your head. Your head is before in the presentation is before.
But normally the screen it should it should
screen
it should show it, you should see you should see the screen and not my head. Since the beginning, you see my head?
Yeah.
Professor Jean-Marie, behind you, we observed your screen, but when you explain the macro, we can observe the construction that you do because your head is high. Your head is high in the screen of the
But,
CABRI Express, so we can observe.
l'écran.
but I don't do anything special. I'm still continuing to share the screen, and you should see the screen. You don't see the screen?
No, the screen is show us in the same time with your head, but it's better that you show only your mm, uh, only your
Et tu t'es pas trompé d'écran, tu montres pas
the
ta
screen complete.
conférence. Je comprends pas.
For example, in this moment, Fernando take a chat of our screen to, and he is going to send you the chat by WhatsApp to observe. Yes, okay. That's
Zoom est là.
that's better.
On voit pas. On voit,
It's better to show us the complete
Visage plus l'écran.
screen of CABRI Express complete, because sometimes when you explain the construction, we can observe the construction.
Est-ce que ça donne un...
Picture. I sent a picture on your chat.
et c'est
Yeah. That's fine.
You should,
It's better. It's better. It's better here. Yeah, that's okay. When you
yeah, but the
le
but normally you are supposed to see my screen in full screen, not my head.
yeah, but it's better if you show us the complete screen.
J'essaye. Hein.
Oui.
Oui, parce que là, on voit là.
Right now.
Yeah, okay, that's good. That's fine.
Tu as choisi présenter.
Well, go ahead. Go ahead. In this moment, we can show your screen, your completely. Okay.
Yeah. Thanks a lot. Thanks.
Thanks. Continue, Dr. Yemari. Thank you very much.
Okay, I will then. It's not easy. I will try to leave my head on the side, but not easy. So, how to construct one tangent line? It's well known, by the way, that this can be achieved using the Theorema de Pascal. The Theorema de Pascal about an inscribed hexagon in a conic. Let me explain restate the theorem. In an hexagon inscribed in a conic, the opposite side can be, if they are extended, they intersect themselves along. We obtain this way 3 points, and those 3 points are on the same line. For instance, here I have six consecutive side of the hexagon, and I put the color yellow for number 1 and 4, etc. And then the two next opposite vertices have color blue, and the two next opposite vertices have color red and red here. If I have already one intersection point here, I can have it like that. I hope it's I made it correctly. Let me check. No, it's not okay. Let me put this point here. And again, another intersection for the two red lines. I will maybe move this a little bit like this and move this here to make their available like that. Put a point here. And finally, for the blue line here, I put a point here. And if I construct a line, simply connecting, so why not this point here to this point here, you see that it goes through the third point here. And this line, I will make it in dotted line to see it, to make it different. And if I change the conic, or if I change the hexagon, you see that the property stays valid for any position of any shape of the hexagon, and also if I move the conic in a different conic, say why not a parabola, is still correct. How can we take advantage of this very nice theorem to have the tangent line? The idea is to take a degenerated case where 2 points, 2 vertices of the hexagon will coincide. And before doing this, I will let you note that there are cases where the theorem of Pascal is very easy to prove, or easier to prove, or is easier to be convinced about the theorem if it's the case where you have both opposite segments. So say the red segment here, we are in a case where they are parallel. The segment yellow are also parallel, and the blue line segment are always also parallel. And of course, their intersection in that case is at infinity. And the line that I was drawing as a dotted line precedingly is now the line at infinity. Let me show you how I could take advantage of the construction in case of 2 points being coinciding. Let me start a polygon, an hexagon. I will start an hexagon like this. A second, another one here. A fourth segment, a fourth side like that, and I need still 2 sides, and I will obtain them then like this. I suppose that some of you recognize here the situation when those 3 points here would be on a line, and where the 3 points here would be on a line. So, I mean, if we would have a degenerated conic degenerated in 2 lines, I would obtain nothing else than considering this line here. I will obtain what is called in that special case the Pappus theorem, the Pappus line, like that. And now I said I would like to have 2 points close, not like that. this point, I will put it close to this one. And you see that when 2 points are close to each other, of course, the matching side will become the tangent line. If I have a conic like this one, this give me a way to construct the conic, because most of this construction here can now be performed using 5 points at random. Let me start with this one per point where I want to have the tangent line. I place a point here, anywhere, and draw this line. I hope it's okay. Yeah, it's okay. Now I continue. You don't see anything now?
Hey.
Ah.
Yeah. Continue, Dr.
I can create
this.
this line here that match this one. Now I can create another line from here to here, anywhere. And from here to here, like that. And from here to here. And the Pascal line, so the line joining the intersection of the points, is here. Connecting this, you recognize the figure. This one here is this one. And this line goes here. And this is the third point of the Pascal line. But this point is on the tangent line. So the line I will now obtain in joining the initial point to this one, to the intersection here. Where is the intersection? Here. The two lines are highlighted in blue. It means the point will be created here at the intersection. This line is a tangent line. Let me check if this is working. I will simply hide the construction line. Hide, like this. Double click to be able to repeat. This is the construction line. This is the construction line. This is the construction line. This, of course, was a construction line. This is a construction line. This is a construction point. This is a construction point. This is a construction point. I suppose I've been hiding all the construction elements. So let me go to, there are still one line here that I was not catching. Let me hide also this one. Now think I can check if this is really the tangent line and check. I mean, I'm sure it will be, if Pascal theorem is correct, this will be the tangent line, and I can simply verify, check that when I move the point here, I obtain the a line which is tangent. And if I would like to be a little bit more sophisticated, I would like to have this line is changing in size when I'm turning because the intersection are jumping away. I could, why not create a circle using this tool here and make a small circle like that. And say, instead of using this line, I will use a different line, which is superimposed to the preceding one, using this intersection here, passing through the other intersection here, and say, again, hide the full line, hide the circle, hide the helping point here and here, and hide the circle. No, I was not, I lost the tool, excuse me. Double click. I need to hide the circle and the point. So the point and the point here. Okay. And now this line, this is the same, geometrically it's the same line, simply that it's defined differently. Now this line here, if I move, you see it stays always with the same length because of the trick of my circle. How can I use this to do a macro if I would like to repeat this construction? You have probably noticed that this construction is not, it's easy to follow, but nevertheless, it's not absolutely trivial. So it means you would prefer to have a fast way to repeat this construction. Let me, if I have a conic now, any conic, so say why not a conic defined from here by 5 points, any kind of conic, a shape like that, why not? If I'd like to to repeat the construction which is encompassed now in this construction, I do simply redefine the point. So I would like to create the tangent line with my macro somewhere on a point on this specific conic. I will change the shape of this point to be sure that I'm speaking about this point. Those points here, they are defining the conic, and this point here is the point where I would like to have the tangent line. I take the redefine, and I put this point redefine here. Oh, it's interesting because it's already let me check this. It's already, for some reason, it's already tangent, but there is no reason it was already tangent because I've just redefined 1 point. Now I continue with my redefinition, and this point, I'll take it anywhere, redefine anywhere. Redefine. So this point, redefine anywhere on the conic. This one, anywhere on this conic. Still not very tangent. And this one, anywhere on the conic. And this is the tangent line. You see, it's a tangent line that I had simply to transport my points. It's a kind of macro, transport the point of the construction where I the construction already exists. This is like a macro, and I transport the defining points. Here I had a construction depending on 5 points. I transport my 5 points on the conic anywhere, and it creates the tangent. So of course, we have, as I mentioned, we went, by the way, also through the theorem of Pappus, and para terminar, I would like to perform a pequeño salto al pasado, and let me try if this work. I hope it works. I'm not sure. Here, 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 and for you, I will remember some very pleasant time we had some years ago.
We can hear you. No, no los escuchamos. Doctor Yemari, no escuchamos el audio.
Qué lástima, no es tan importante porque el texto, you can read the text?
Yeah, we can read the test.
It's small, but so muchas. Gracias, gracias.
Ok, doctor Yemari.
Y muchas gracias a todos para escuchar.
Muchas gracias.
Gracias.
Un aplauso, por favor. Muchas gracias. Bien, muchas gracias. Vamos a las secciones de preguntas. Entonces, primero con las personas que están en el auditorio. Profesor Fernando, quisiera mencionar algo del video, porque es que no se escuchó. Ya. Eso fue en el 2016.
9 años, casi 10 años, ¿no? En la Universidad de Medellín, evidentemente decía un poco parecido a lo que hoy repetí. Le decía que CABRI, los que somos usuarios de CABRI, esencialmente, es un gran regalo del profesor Yamari. Es el creador de CABRI en la Universidad de Grenoble, y le decía que para nosotros era el segundo mejor regalo después de los derechos del hombre que fueron traducidos y que hoy generosamente nos recordó el profesor Jean-Marie por Nariño, ¿no? Por don Antonio Nariño. Acuérdense que al comienzo le hizo un tributo a nuestro departamento el profesor Jean-Marie. Y justo le decía, el traductor de los derechos del hombre fue Antonio Nariño, al que allí de nuevo lo presenta en la imagen que posiblemente fue él, ¿no? Pues muchas gracias, profesor Jean-Marie. Nosotros estamos contentísimos. Le vamos a apuntar y a apostar a seguir trabajando en la geometría. Mire cómo yo no lo sabía sino hasta hace unos 15 días. El profesor Jean-Marie recibió uno de los más grandes tributos que Francia le puede rendir a un nacional, ¿no? Que es la Legión de Honor, nos lo decía el profesor Edison, nos lo repetía, estatuido ese tributo por Napoleón Bonaparte. Imagínense, estamos en esta ocasión no con cualquier profesor, sino con un profesorazo de verdad a nivel mundial. Por eso lo presenté, profesor, recuerda usted, como uno de los mejores matemáticos vivos del mundo moderno. Thanks a lot, teacher, again. This Wednesday is for me a perfect day. ¿No? Thanks a lot. Y animarnos, ¿no? Animarnos a trabajar. Entendimos muy bien lo último sobre el teorema de Pascal. ¿Cómo se llama, Saulo? El hexagrama místico de Pascal, con el cual el profesor alcanzó a trazar sobre una elipse la tangente y ver cómo se puede hacer una macroconstrucción que no lo tiene CABRI Express así tan fresco, pero lo puede hacer. CABRI Express es la versión gratuita de CABRI y tiene unos alcances didácticos que no tienen los otros CABRI. Es gratuito, ustedes lo pueden bajar pues en sus equipos y explorar, es ponerse a trabajar en él. Tiene unas cosas bellísimas. Por ejemplo, yo ahorita mismo estoy trabajando sobre sucesiones con CABRI Express, porque bota términos, números racionales. Una belleza que he encontrado, y con el profesor Jean-Marie hablábamos un poquito de por qué es que en mi tarea apareció el concepto de límite con CABRI Express. O sea, hay que explorar, es muy intuitivo y es muy racional, digamos, ¿no? No sé si Alicia por allá tiene alguna otra pregunta desde Argentina. ¿Todavía estás en sala, Alicia?
Sí, profesora Alicia, ¿todavía sigue con nosotros? Ya, la profesora Alicia todavía sigue con nosotros, sí, creo que está conectada. Sí, si nos quería comentar algo. No, no le escuchamos, profesora, por favor, su micrófono. No, no, no le escuchamos.
Il faut appuyer sur ton micro. Sur l'écran, il faut appuyer ton micro.
El micrófono de la profesora Alicia que no está activado.
Ah, ahora sí.
No, el micrófono para en Zoom, por favor. ¿Sí? ¿Cómo se activa? No, no, no. Ella está hablando, pero no lo podemos activar.
La conexión con la inteligencia artificial me parece muy interesante y que voy a querer seguir estudiando eso porque no me imaginaba que se podía relacionar CABRI con este tema.
Ah,
Ahora sí, ahora tengo libre.
Ya, ya.
Bueno,
Gracias.
ahí está.
Profesora, si puede repetir de nuevo, que si no la escuchamos muy bien. También le vamos a dar la palabra aquí a alguien.
¿Cómo no? Bueno, lo digo en castellano, después lo digo en francés. Me interesó muchísimo también a partir de poder crear una macro, me parece espléndido eso. Sinceramente, siempre nos trae Jean-Marie temas nuevos como para que nosotros sigamos estudiando, es decir, que nunca nos cansemos de seguir estudiando. Pero también me pareció excelente el vínculo entre CABRI y la inteligencia artificial, cosa que no, yo por lo menos no me imaginaba que se podía llegar a hacer. Je explique en français, Jean-Marie, ou bien tu as compris tout ce que je dis?
Non, j'ai compris ce que tu as dit. Merci beaucoup. Ça me fait plaisir parce qu'effectivement, je crois qu'il est important de montrer que les algorithmes d'intelligence artificielle ne sont pas magiques. C'est des réalités et qu'on peut montrer comment elles fonctionnent concrètement et montrer qu'est-ce que c'est qu'un apprentissage automatique.
Merci, merci beaucoup. Bueno, lo que dijo es que él lo que quiere mostrar es que los algoritmos de la inteligencia artificial no son mágicos. Ojo, esta es una interpretación mía, no uso esa palabra, pero que es importante que entendamos cómo funciona la inteligencia artificial y que se puede conectar con todo esto.
Bien, muchas gracias. Aquí dentro del público tenemos a nuestros estudiantes, futuros profesores de matemáticas. Bueno, queremos darle también la palabra aquí a las personas que están aquí presentes y luego volvemos otra vez al Zoom. Hay profesores también de la Universidad Pedagógica y Tecnológica de Tunja. Están conectados varios profesores también de la Universidad de Tunja, en Tunja. Hay otros profesores también de la Normal Superior Farañones de Cali, desde Cali, de la Universidad del Valle. Bueno, preguntas. Alejandro, una pregunta para el profesor Yamari. Ya. Wilmer, una pregunta. Por favor, me enfocas aquí a Wilmer para que el profesor Yamari nos observe. Sí, no, Wilmer va a hablar en español y creo que el profesor Yamari le entenderá.
Sí,
Ah,
gracias. Sí, eso vale.
Profesora Alicia, ¿nos podría hacer el favor de traducirnos las preguntas que tenemos aquí en el público presencial? No, no le escuchamos, no le escuchamos a la profesora Alicia. Bueno, Wilmer, por favor, en español, claro.
La pregunta que tengo es más que todo como una duda. Me gustaría saber qué tan cerca está una construcción en CABRI de una demostración formal de algún resultado en matemáticas.
Bien, Wilmer, gracias. Muchas gracias por tu pregunta.
No sabe seguro si entiendo bien la pregunta. Lo que puedo hablar es que CABRI o los otros software dinámicos no ofrecen directamente pruebas formales. Ofrecen la posibilidad de validar ideas para construir la prueba formal. Es una ayuda muy importante para verificar que esta idea es buena o esta idea no funciona. Y pero como le digo, no
Hola.
no ofrece directamente la prueba formal.
Claro.
Bien, gracias, Wilmer. ¿Más
No
preguntas?
es una, para mí no es un desavantaje, no es una es mejor si el software puede dar la prueba formal, entonces, ¿por cuál razón necesitamos aprender matemática? ¿Entiendo?
Sí, muchas gracias, profesor Jean-Marie. Vamos con más preguntas. Jóvenes, aprovechen que tenemos aquí al profesor Jean-Marie con nosotros. No, es un honor para nosotros tener aquí al profesor y pues tener una persona importante en educación matemática en el mundo, tenerla aquí en nuestra universidad. Profesor, ¿más preguntas? ¿Profesores? Bueno, vamos a las preguntas que hay allí en el Zoom. Creo que en el Zoom hay también preguntas. Si tienen preguntas. eh, para las personas que están conectadas, ¿alguna pregunta para el doctor Yemarí? Puede activar su micrófono y hacer la pregunta. No, no, ¿alguna pregunta? No, no. ¿O alguien que alce la mano? ¿Sí? Bueno, entonces vamos a despedirnos de... ¿Sí? ¿Más preguntas? En el chat. Vamos a mirar más preguntas en el chat. A ver, en el chat. Eh, a ver, en el chat estoy viendo que están saludando de la maestría en educación matemática desde la Universidad Pedagógica y Tecnológica de Tunja, en Boyacá. Nos están saludando. Mm, no sé si haya preguntas. No, 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 no. Parece que no hay preguntas. Bueno, vámonos entonces, vámonos a despedir del profesor Yamarí. Profesor Yamarí, los profesores que nos están acompañando en nuestra conferencia de hoy. Profesor Fernando.
Bueno, muchas gracias. Realmente este es un miércoles académico súper especial. Abre la compuerta, como ya lo hemos dicho, a que otros grandes maestros también nos acompañen en próximos miércoles. Ya la amenazamos, Alicia. ¿Me estás escuchando, Alicia, no? Ya quedas cordialmente amenazada para que nos acompañes otro miércoles. Este es un proyecto muy bonito, son los miércoles 10 de la mañana. Estarás con nosotros en una de tus charlas, ¿verdad? Estás comprometida, ¿verdad? Con mucho gusto, lo dice, le entendemos por señas. Estará también Eugenio Díaz Barriga, algunos otros colegas que los hemos concitado. Nuestro proyecto era esencialmente presencial, pero hemos abierto esta compuerta que a la brava nos lo enseñó la pandemia, ¿no? Y es un buen recurso para tener amigos que están obviamente viviendo en otros sitios del orbe, ¿no? Muchas gracias. Thanks a lot, teacher. Jean-Marie, Professor Jean-Marie, this is a very special day for us. As you
Okay, thank you very much. Disculpe que, que no es que ma figura en frente de la pantalla.
Yeah. Don't worry. Thanks a lot. And perhaps another day we can see personality.
Okay.
That's fine. Thanks for everything. And
Gracias. Gracias, muchas gracias.
muy amable. Un nuevo aplauso al profesor Jean-Marie. Muchas gracias a todos.
Sí.
Muy amables por su presencia también. Gracias, profesor.
Muchas gracias a todos y éxito.